Now, still talking about routing, in this case, we're going to talk about Route 53. And you should already know about Route 53. You should know what it does and what a DNS is, what the different types of DNS records are, Route 53 concepts like an alias or a hosted zone. And so a little bit of trivia here. Do you know why it's called Route 53? Well, it's because the DNS service port is 53. So Route 53 has multiple policies that we can use. And again, similarly how I've done in the past, I'm going to lay out the policy and then try to translate that into what Route 53 is thinking when it's trying to execute that policy. The first policy we have is just the simple policy, and it's simple. It's just we're creating an entry, a DNS entry, and Route 53 is saying, okay, here's the destination for that name. Then we have failover. And so Route 53 would be thinking, normally I'd route you to this primary place, but it appears that it's down based on my health checks. So I'm going to fail over to this other backup system and send you there instead. Then we have geolocation. And what Route 53 is thinking there is, hey, looks like you're in Europe, so I'm going to route you to a resource closer to you in that region. Then we have geoproximity, and it's different than geolocation. So Route 53 is thinking, hey, you're closer to US East 1 region than US West 2, so I'm going to route you to US East 1. Then we have latency, which says, let me see which resource has the lower latency from you, and then I'm going to direct you that way. Then we have multi-value answer, and this is where Route 53 can return several addresses. It's kind of like a sort of basic load balancer. Then we have the weighted policy. And Route 53 allows us to set up multiple resources, and we can assign a weight, and it will distribute the traffic based on that weight. Let's take a look at each type and see what the behavior is when we issue a dig command, for example. So here I'm just creating a basic simple route policy, and I'm pointing it to an IP address. And as you can see, it's returning the address 52.11.7.197. Pretty simple. Now I'm going to set up failover routing. So I'm going to create a record with the same name, but different IP addresses. And I'm going to say that it's a failover of a primary and then a failover of a secondary. And I'm going to have a health check associated with the primary. What I've done prior is set up that health check. And really all it does is just pings and tries to hit my primary resource. And if that's unavailable, then it's going to send me to the secondary route or the secondary resource, which in this case is 120.13. So here's what it looks like. Before I stopped my primary instance, it was sending me to the 197 address. And then after I stopped the instance, it sent me to the 113 instance, which is exactly the behavior we were looking for. And now for geolocation routing. So I can configure a route for North American users, for example, here on the left-hand side. And then I can also configure a default route for everyone else. Now, a special note here, it's important that you have a default route for geolocation because sometimes Route 53 won't be able to determine where the person's coming from. And so the default route is kind of the catch-all. And you can see this time I'm using a CNAME, so I just wanted to demonstrate that we can indeed use many different types of DNS records. So on the top, I'm in a system that's in the USA, and I'm going to issue my NSLOOKUP command, and it's going to show me the IP address 120.113, and it resolves to US East 1. Now on the bottom, I'm on a machine that's in Germany, and using the same command for the same name, it's directing me to a different IP address. For geoproximity, I'm not going to show you a screenshot since it would be hard to see, but here's the concept of geoproximity. Let's say we have US West 2 and US East 1, and let's say somebody lives in the little yellow marker there, that's probably about St. Louis. So let's say that we're distributing traffic across two regions based on location. And those closest to one region would go to that region. So in our example, the requester at the yellow map marker would route to the US East 1 resources. But let's say that we wanted to shift more geography to one region. We can change the bias on the geoproximity record, and that has the effect of increasing or decreasing a radius around which we route traffic. And the bias can be between -99 to +99. And a positive bias will increase our circle, and a negative bias will decrease our circle. And in our case here, the yellow marker would route to US West 2 resources because it's now within the positive bias circle of US West 2. So why would I want to do this? Well, let's say that using proximity, my US East 1 resources are maxed out just due to the larger population on the east side of the country. Adjusting the bias would allow me to more equally distribute the load across my regions. Now, latency-based routing is when we can route based on, well, latency. So in this case, we have two records. We have a record that's set up to serve when latency is lower to the US East data center. And then we have one that's set up to serve when latency is lower to EU Central. So this is different than geolocation because it's not really based on geography, rather it's based on the latency between that requester and ultimately the data center. So we can see this in practice. If I log into a machine in the USA, I'm going to get directed to US East 1. And then if I happen to be logged into a machine in France, for example, where presumably the latency between that machine and EU Central 1 is going to be less than the latency between US East 1, it's going to direct me to the European system, in which case it did. Now, multi-value answer routing is useful when you want to have the same name pointing to multiple IP addresses. And you can also set up health checks so that only healthy endpoints would be served. And this is kind of a very basic load balancing or round robin type direction of traffic. So in this case, if I use my NSLOOKUP command, I'm getting back multiple IP addresses, and I can choose any one of those IP addresses. Now, if I happen to try to visit one of those IP addresses and it comes up dead or unresponsive, then my client's automatically going to just reach out for the next IP address. Now we have weighted routing. In this case, we have two records with the same DNS name. One is going to US East 1 and one is going to EU Central 1. And you can see the weight is 10, it matches. And so what this will do is this will route traffic equally to both of those destinations. Now weight numbers can be anywhere from 0 all the way up to 255. And if I set it to 0, then that has the effect of disabling traffic going to that endpoint. So here, if I execute my NSLOOKUP command, I have an equal chance of getting either endpoint. The formula for weighting is pretty simple. It's the sum of all weights is the denominator, and the numerator is the weight for a specific record. So that's going to define what percentage of traffic goes to what destination. So let's look at that in terms of some examples. So if we have weight for endpoint 1 as 10 and endpoint 2 as 10, well then each endpoint is going to get 50% of the traffic. Now if I set the weight for endpoint 1 as 0, and endpoint 2 can be anything, it can be 1, it can be 255, whatever. As long as endpoint 1 is 0, then endpoint 2 is going to take on 100% of the traffic. And this is a common way to transition traffic away from certain instances that you maybe want to take offline, like maybe through a blue-green deployment where you might want to gradually meter the traffic across your instances.